This is the lesson for Chapter 8, Review, Chapter Review. So let's take a look at all the different types of problems that we're going to end up seeing on this assignment. So number 12 here, and these come directly from the problems that I assigned, except just different numbers. So here we're adding these two polynomials together, and the key is to make sure you line up the terms with the same variables raised to the same power. So I'm going to combine the negative v to the third with the 2v to the third, the positive v with the negative v, and then minus 3 with the positive 8. So when I add that together, I end up getting 1v to the third power, and then the v's cancel out here, so I'm just left with a positive 5 left over. So v to the third plus 5 would be that answer. With the subtraction, make sure you add the opposite. So watch what I end up doing with these signs, though. So I'm changing subtraction to addition, taking the opposite of all these terms, and then I'm lining up the terms with the same variables raised to the same power. And so once I do that, I can combine them together. So that makes 9h to the third minus 3h and a plus 3. So the common mistake is people still end up changing the exponents when we add, but you can't do that. You can only do that when you multiply, because exponents represent repeated multiplication. So here's an example where we'll change exponents. So I'll multiply q by each of these terms. So I'm left with 11q plus, and then 8q squared, and then minus 2q to the third. So we want to write it in the standard form. Standard form means descending order, so highest exponent to lowest exponent. So negative 2q to the third plus 8q squared, and then plus 11q. That would be descending order from highest exponent down to lowest exponent. Make sure you commute the sign in front of the term. So here we're trying to factor out the GCF, the greatest common factor. So I see 3 goes into each of these terms, but also they each have at least one b. So I'll pull out a 3b. On the outside of a set of parentheses, do the division, and I'm left with b to the third minus 3b, and then plus just 2. And that would be our answer. Well, the next set of problems asks us to multiply. So when we've got a binomial that's squared, just write it out twice, and then use FOIL. And so I'm multiplying the first terms, so first, outer, inner, and last. And so my first terms make 9r to the second. Outside terms make a negative 6r, and messed up there a little bit. I put in that extra minus sign. I already had one. And then my inside terms make the same thing. That's what you're going to see with the binomials being squared. Inner and outer are the same, and the last term will always be positive because two negatives make a positive. So these two will combine together. So I've got 9r squared minus 12r plus 4. Well, looking at the next one, I multiply 6g times g, so I'm getting 6g squared. And those are the first terms. Outside terms make a negative 48g. Inside right here make a positive 7g. And the last terms, 7 and negative 8, make negative 56. So when I collect these two terms, well, they'll subtract because they're opposite in sign, but I'm still left with negatives. So negative 41g minus 56. And I got the 6g squared up top. So the next set of problems asks us to factor. So when we factor, always look for common factors. See if you can take anything out to make the problem easier. I see 2 goes into each of these terms, and now I'll have an easier time factoring this trinomial. So notice how you got 2 variables. And when we deal with that, what we're going to end up doing is remembering that when we go ahead and draw the 2 sets of parentheses, we're going to have an L as the last term. So L times L makes L squared. And we also know the signs. We also know that they both have to be negative because 2 negatives make a positive, and the outside terms and inside terms are adding to make negative 5k. So I need the first terms to multiply to make 3k squared. So I'm going to try 3k and k, make 3k squared. Now, I want the outside terms and inside terms to add together to make negative 5k, L. And so I've already got a 3kl here, so I'm going to end up multiplying this by, make this a 2. And this is going to make it negative 2lk, and I've got negative 3kl. I'll just write lk for there, and those add together to make negative 5kl. Just add that 2 to the end, and you've got your answer. This one's a little bit tougher because there's no common factors. And so I'm just going to draw the 2 sets of parentheses, and noting the sign here, negative. That means the outside terms and inside terms are going to subtract to make 11v. So my guess is I probably need to break down the 10. And so I'm going to break it down to 5v and 2v. And now I'm going to try some different options that multiply to make 8. I've got 1 and 8, and I also have a 4 and a 2. And so if I try the 1 and 8, I don't want to multiply 5 by 8. But if I do multiply the 5 or the 2 by 8, that'll make 16. And if I do 5 times 1, that'll make 5. And those two numbers do subtract to make 11. So we figured it out. Now we just need to figure out the signs. So we need a positive 16 and a negative 5. So put the minus sign with the 1 to make that a negative 5. And so that'll end up working. So box that answer. So let's take a look at the next set of problems. And here we have to factor some more. So on these problems, one of the factoring techniques is if you see a perfect square, like 9p squared is a perfect square and 49 is a perfect square, try it as a trinomial square, which means the two binomials would be the same. So 3p and 3p multiply to make 3p squared. 7 and 7 multiply to make 49. Two negative signs there because the outside and inside terms add to make negative 42p. Let's check and see if it works. Negative 21p for the inside terms. Outside terms make a negative 21p. And those two do add together to make negative 42p. So it does work out, matches. So we can write the answer as 3p minus 7 quantity squared. Well, this is a binomial. Anytime you got a binomial, it will only factor if it's a sum and a difference. And that means both terms have to be perfect squares. If they're not, look to see if you can take out a common factor. So 25x squared would be 5x and 5x. 6 times 6 makes 36. Put a minus sign and a plus sign, see what happens here. So you see 5x times 5x again makes 25x squared. 6 times negative 6, negative 36. You see how the inside terms and outside terms are opposite in sign but same number, and so they cancel out to make 0. So it works. So the last type of problem is a factor by grouping problem. Well, look for common factors. Always do that first. And so I can see a 2d can be pulled out from each of these four terms. So I'll pull that on the outside of a set of parentheses, do the division, see what's left over. I've got 3d to the third plus 2d squared minus 3d and a minus 2. Now I'm going to go ahead and factor by grouping. So that works this way. You group the first two terms, and when this is negative, you have to add the opposite there to make sure you see that that 3 is actually negative and not positive. So I look for common factors. All I see here is d squared. So I'll pull out a d squared. So I still have this 2d. I'll just keep it inside some parentheses there. And then I've got now d squared multiplied by 3d plus 2. Well, I already have a negative 3d minus 2, so I'm going to take out a negative 1 from each of these terms, and that means I'll put the minus 1 on the outside, do the division, and I've got a 3d plus 2. So what's common? Well, what's common is the 3d plus 2, so I'll pull that on the outside of a set of parentheses, and I still have this 2d as well, and then what's left in here is a d squared minus 1. Now, actually, on this problem, I'm not done yet, because this is a difference of squares. You see, whenever you have a perfect square and another perfect square, and they're separated by a minus sign, that means it factors a little further. So we still have the 2d. I have the 3d plus 2, but also the d squared minus 1, that factors to a d plus 1 and a d minus 1. So there are actually 4 different factors for this problem. So those are the types of problems that you're going to see on tonight's homework. Good luck.